Hi students, now we are going to study the fifth module of signals and systems. That is a transform. Okay, so is a transform is mainly considered in the case of discrete time systems. So is a transform is used for the analysis of LTI discrete time systems. So you see what is the equation for is a transform of the given signal x of n. Okay, so x of n is a discrete time signal. So the definition is that the is a transform of the discrete time signal x of n is defined as x of z is equal to summation n equal to minus infinity to infinity x of n is raised to minus n. Okay, so where x of n is the given signal and z is a complex variable. So the polar form of z can be expressed as z is equal to r e raised to j omega. Okay, so where r is the radius of the circle. Okay, so where what is meant by that circle? So in z transform, when we consider about the ROC, we are considering ROC around a circle in the z plane. Okay, so that circle that circle's radius is known as the r. Okay, so we know the equation for z transform x of z here, and here I have write that z is equal to r e raised to j omega. Now we are going to rewrite the first equation by using this expansion for z. So x of r e raised to j omega is equal to summation x of n r e raised to j omega the all raised to minus n. Then opening the bracket in the RHS, we will get summation x of n r raised to minus n e raised to minus j omega n. So we are considering that we are having a unit circle. So we are considering is a transform in the case of a unit circle, that is, which means its radius is equal to 1. Okay, so that is r is equal to 1. Then we are substituting r equal to 1 in this equation. We will get x of e raised to j omega is equal to summation x of n e raised to minus j omega n. So here the r term become 1. Okay, so what is this equation? This is the equation for the Fourier transform of discrete time signal. Therefore, the Z transform evaluated on the unit circle corresponds to the Fourier transform of discrete time signals. So, this is the relationship between Z transform and the discrete time Fourier transform. Okay. So there are certain points we need to remember. The equation for x of z is summation x of n is raised to minus n. So here the limits for the summation is from minus infinity to plus infinity. Okay, so we can say this equation is two-sided is a transform. Okay, so whereas in case of a causal sequence, so what is the speciality of causal sequence? That's x of n will be 0 for n less than 0. So it is causal means a right-sided sequence, that is it exists only for the positive values of n. And if we consider that type a causal signal or causal sequence, then its a transform will be like this x plus of s, because plus sign is here because we are considering causal signal or positive sided signal. Okay, so x plus of z will be, our limit will be changed from 0 to infinity. So it is right sided causal. So x of n is raised to minus n. So this is known as one sided z transform. Okay. So now we are considering about ROC. So what is the definition for ROC, അതായത് region of convergence in case of is a transform. So region of convergence in case of is a transform is a set of values of z for which x of z attains a finite value. So what is meant by the ROC in case of z transform? It is a set of values of z. So values for z that gives x of z a finite value. Okay, so this is the ROC in case of z transform. Okay, so now let's see what will be the ROC in case of a causal and anti-causal sequence. We know that causal signal means x of n is equal to 0 for n less than 0. So, for a causal sequence, ROC is the entire Z plane except at Z is equal to 0. So, ROC of a causal sequence will be the entire Z plane except at Z equal to 0. So, let's study detailed in this point based on an example. So, see this example. So, they are asking us to find the set transform and ROC of the sequence x of n is equal to 1, 0, 3, minus 1, 2. So, from here, the origin of the signal is the value of the signal at the origin is 1. Okay. So for negative side, the signal does not exist. It is only exists for the positive side. So 0, 1, 2, 3 up to 4, the signal exists. So which means that the sequence is a causal sequence. Okay. So we know the equation for Z transform, and we are writing the equation for Z transform, and since our signal is x from 0 to 4, n is equal to 0 to 4, we have to rewrite the summation limit like this. Summation n is equal to 0 to 4, x of n z raised to minus n, and we are expanding the summation, and we will get like this: x of 0 is raised to minus 0, like that up to x of 4 is raised to minus 4. And we know the equations for x of 0 to x of 4 from the question itself, and we are substituting values here, and we will get the transform of the given sequence like this. Okay, so if we put z is equal to 0 here, we will get infinity. That is x of z as infinity. So other than any values except 0, the x of z is having a finite value. Only in the case of z is equal to 0, x of z tends to infinity. So which means that x of z converges for all values of z except at z is equal to 0. Okay, so from this we can understand that for a causal sequence, the ROC is the entire z plane except z is equal to 0. Okay. So now let's consider about an anticausal sequence. So what is the speciality of anticausal sequence? For anticausal sequence, x of n is equal to 0 for n greater than 0. And for anticausal sequence, ROC is the entire Z plane except that Z is equal to infinity. So in case of causal sequence, ROC is the entire Z plane except Z is equal to 0. Here in case of anticausal sequence, ROC is the entire Z plane except Z is equal to infinity. So let's consider one example for that. So find the Z transform and ROC of so n is equal to minus 3, minus 2, minus 1, 0, 1. Okay. And the origin is located at, our value for the signal at n is equal to 0 is 1. So for the left side of the 1, 0, the signal exists. In the right side, there is no signals. So which means that the given signal is an anticausal sequence. And the signal is accessed from minus 4 to 0. So we are writing the equation for the is a transform, and we are rewriting the equation by considering the limits in the given question, and it is from minus 4 to 0, x of n is raised to minus n. Okay, so and on expanding the summation, we will get like this. From the question itself, we will get the values for x of minus 4, x of minus 3, x of minus 2, up to x of 0. And finally, we will get x of z as minus 3 is z raised to 4, minus 2 is z cube, minus z square plus z. So what happens if we put 0 here? So if we put 0 for z, we will get x of z as 1. So it is a finite value. And what will happen if we give infinity here? So if we will give infinity to the z, x of z becomes infinity plus 1. So infinity plus 1 means infinity itself. So any value other than infinity, x of z is having a finite value. But for z is equal to infinity, x of z also tends to infinity. So which means that X of z converges for all values except at z equal to infinity. That is, the ROC here is entire z plane except at z is equal to infinity. So this is in the case of anti-closing sequence. So what happens in the case of a two-sided sequence? The signal that has finite duration on the left and the right side is called two-sided sequence. So the ROC for such sequence is the entire Z line except at Z is equal to 0 and Z is equal to infinity. That is, in case of a two-sided sequence, it is a combination of an anti-causal and non-causal. So here the ROC is the entire Z line except Z equal to 0 and Z equal to infinity. So, now let's consider one example. So here they are given a two-sided sequence because one middle signal is given as the origin, or the value corresponds to n is equal to 0. So it is a two-sided sequence. It exists from -4 to +4, and we are finding the Z transform by using the equation. And let's see, we will get the Z transform like this. And let's check what happens if you put Z is equal to 0. So Z equal to 0 means here first term, second term, third and fourth term will become 0 and fifth term will be 1, like that. When we put other last three terms in z as 0, it will become infinity. So when we put z equal to 0, it will give infinity. And when will we give z equal to infinity? Except last four terms, the rest of the terms will be infinity. So other than is 0 and infinity, whatever value we given to z, the signal give the x of z will give a finite value. So which from this we can understand that x of z converges for all values of z except at z equal to 0 and z equal to infinity. So this is all about the Z transform introduction and ROC in the case of a left-sided, right-sided and two-sided sequence. Thank you.